Welcome, everyone. Thank you for being here today. My name is Mia Tamburi, and I am the Program Director of Cancer Bridges, and I participate in the Education and Outreach Work Group for the Cancer and Environment Network of Southwestern Pennsylvania. Today's presentation is part of a speaker series project that was initiated by this work group. The Cancer and the Environment Network of Southwestern Pennsylvania is composed of organizations and individuals who are concerned about environmental chemicals and how they are contributing to our region's high rates of cancer. The organizations co-sponsoring today's webinar are Cancer Bridges, formerly our clubhouse and cancer caring center. At Cancer Bridges, we provide support for those impacted by cancer, including counseling, support groups, health and wellness classes, family and youth activities, and much more. Young Adult Survivors United, a community in Western Pennsylvania for young adult cancer survivors and their co-survivors, and the Leukemia and Lymphoma Society. LLS focuses on blood cancers and improving the quality of life for patients and their families through research, education, policy, and advocacy. The websites for these organizations will be found in the chat. Now I want to introduce today's speaker. Dr. Robin Dodson is a research scientist at the Silent Springs Institute and an expert on chemical exposure and risk assessment, particularly in the indoor environment. Her research focuses on three main areas: development of novel exposure measurements for epidemiological and community-based studies, analysis of environmental exposure data with a particular emphasis on consumer product chemicals, and intervention studies aimed at reducing chemical exposures. Dr. Dodson completed her master's in environmental science and risk management and her doctorate in environmental health at Harvard T.H. Chan School of Public Health. She is an adjunct assistant professor of environmental health at Boston University School of Public Health and is a visiting scientist at Harvard T.H. Chan School of Public Health. Dr. Dodson has dedicated her career to improving public health through her applied research and hopes to inspire a new generation of young girls to become future scientists. Dr. Dodson is going to speak with us for about 45 minutes, and then we will have time for questions. You can put your questions in the chat and we will answer them at the end. Dr. Dodson, thank you for being with us today.
Thank you very much. I'm excited to be here. Let me go ahead and share my slides here. So I'm really excited today to be able to talk with you about some of our research on the links between breast cancer and the environment. And as Mia had said, I'm an exposure scientist, so I'm going to focus a lot on kind of thinking about ways that we characterize exposure to chemicals that are relevant for breast cancer, and then sharing some opportunities for trying to reduce our exposure to those chemicals. So you'll learn today in the webinar how to define genetic environmental risk factors that are linked with breast cancer, how to talk about endocrine disrupting chemicals or EDCs and where they come from, and finally opportunities at multiple scales to try to limit exposure to chemicals that affect cancer. So first, I just want to start off with a little bit of background of my organization. So Silent Spring Institute is a nonprofit research organization. We're located in Massachusetts that studies the link between the environment and women's health with a particular focus on breast cancer. We were founded over 25 years ago now by activists with the Massachusetts Breast Cancer Coalition, who were seeking to identify or kind of put more resources towards research that could look at the environmental influences on breast cancer. They had noted that there were relatively high elevated rates of breast cancer in Cape Cod, Massachusetts, and the traditional risk factors could not explain the elevated rates. So with some state funding at the time, they started Silent Spring Institute, termed at that time that we called it a lab of our own, and we have dedicated ourselves since to looking at the environmental contributors to disease, including breast cancer. So first I want to talk a little bit about why we want to think about the environment. What is the importance of thinking about the environment relative to our breast cancer risk? So first, let's start off by taking a poll. The poll is, what % of breast cancer cases are attributable solely to genetic risk factors? if you could click which answer you think is correct. Looks like a bunch of you have submitted your answers. So we can see here that about half of you had selected 1 to 30%. Another 45% or so selected 31 to 60%. And several, I guess 2 folks thought that 60 to 90% of breast cancer cases are attributable to solely to genetic risk factors. So you may actually be surprised, maybe not all of you, but a good chunk of you, nearly half of you, may be surprised to learn that, hold on, I'm just trying to clear that. Okay, here we go. That actually only about 80% of women with breast cancer are the first in their family to be diagnosed with breast cancer. What that means is that less than 10% or so are attributable to those high risk genes like BRCA1 and BRCA2. We know this from some twin studies that show maybe around 25 to 30, maybe 30% of breast cancer cases can be attributable to genetic risk factors alone. What that means is that the rest of the breast cancer cases, that 70% of breast cancer cases, are attributable to other factors, and that includes environmental factors. And part of that includes lifestyle factors like exercise, alcohol consumption, but it also includes chemical exposures. In fact, there's mounting evidence to suggest that chemical exposures in our everyday environment are important, but they're often overlooked contributing factors to breast cancer. These chemicals are in our everyday lives. They're in the air we breathe, they're in the food we eat, the water we drink, the products that we use every day. And many of them have been linked to breast cancer. Unfortunately, we know that we're widely exposed to these chemicals. And I'll talk about where those are. But first, let's just talk about how we think about identifying causes of cancer. So taking a step back, when we think about studies that often are used to reveal cancer causes, we often think about, we often require the very big studies, these high, well-defined exposures among very, very large groups of people with very systematic follow-up of cancer incidents. So you need a lot of people, you need a lot of information about these people over time as we think about cancer development. Now, many cancers, including breast cancer, are long latency. That means that you have to systematically follow up individuals over extended periods of time, maybe decades. You also need a very clear definition of those who might be exposed or unexposed. We call this, when you don't have this, we call this exposure misclassification. So what this means is that you need lots of people, lots of time, and lots of detailed information about those people, starting perhaps even decades ago. And what that means is that many of the studies that we use to link causes of cancer are large occupational studies that mostly include men. And when they do include chemicals, they're looking in occupational levels, so typically rather high levels of exposure. And when they're looking at the cancers, they're certainly not looking necessarily at the breast tissue. What this means is that there's been a lot of occupational studies on cancer, not a lot of work on breast cancer. And that's not because women have not been working during this time. It just means that women haven't traditionally been working in spaces where there are jobs where there'd be long periods of follow-up. So there's pensions, there's health insurance. It means that a lot of these kind of missed opportunities for identifying some contributions to breast cancer risk have gone unnoticed. But There are some instances that places where we can look for some contributions to breast cancer, and that includes things like accidents or disasters. This can be in chemical plant disasters or things like ionizing radiation. Also into the pharmaceutical literature, where we know that, for example, hormone replacement therapy has been associated with increased breast cancer risk. So let's talk about hormone replacement therapy a little bit more as a kind of a model for thinking about how exposures, in this case, exposure or use of a pharmaceutical, could actually increase breast cancer risk. So what I'm showing here on the left here is age-adjusted annual incidence rates for invasive breast cancer. The top row, actually, the top two rows are for women, the green and the kind of lighter olive green there, are women over 45 years of age. So they are perimenopausal or postmenopausal. The blue line there, sorry, it's not labeled, is for all women. And then down at the bottom there are women that are less than 45 years of age. When we look at these data, we can actually see that there was a steady increase, about 25%, if you look from the early 1980s until about 1992 or 1993. Then there was a kind of an additional increase or bump up at about 15% between up until about 2001. And then you can actually see a drop starting at about 2001, and then things have edged up slightly. What we're seeing here is likely the result of actually a shift in how women have used hormone replacement therapy. There was a Women's Health Initiative study, a large-scale study that was evaluating the efficacy of combined hormone replacement therapy on cardiovascular health among women, as well as breast cancer incidence in the early 2000s. But the study was actually, this randomized large clinical trial was actually stopped in the early 2000s because they discovered that the risk outweighed the benefits. Namely, that they were seeing higher incidence of breast cancer among women who were taking the combined hormone replacement therapy, and they stopped the trial. The result was that there was kind of a shift in how women dealt with perimenopausal symptoms, and there was a rapid decline in combined hormone replacement therapy. And I think we can see that here in the incidence rates. In a subsequent analysis in 2014, Roth et al. Had showed that the change away from using combined hormone replacement therapy meant that there was 4.3 million fewer users of the therapy, but there were also 126,000 fewer breast cancer cases, and a total expenditure savings of over $35 billion. So what I take away from this is that, and this is because we're seeing this, there's millions of users of these hormone replacement therapies, but we can see when that drops off, we actually see a decline in the annual incidence rates. And this is really important. It means that prevention is possible. And we can see it at this large scale here. So what about environmental chemicals? So, right, we can see in the pharmaceutical example with combined hormone replacement therapy, but what about the chemicals that we encounter in our everyday lives? Well, there's growing consensus that there are important environmental contributions to breast cancer, and that hazardous chemicals in our everyday environment are important and often overlooked. This was highlighted in the President's Cancer Panel annual report that focused on thinking about environmental risk factors to disease or to cancer. And that was followed by the Institute of Medicine's report on breast cancer and the environment. It means that we're starting to see a shift in the way that scientists and physicians think about ways to prevent breast cancer. Rather than waiting for definitive proof of certain chemicals cause human harm before acting, many experts are now calling for a new emphasis on cancer prevention that includes eliminating and reducing people's exposures to toxic chemicals. So now I'm going to tell you a little bit about how we study the environmental contributions to breast cancer. This is actually a kind of a new kind of paradigm for thinking about cancer prevention that our executive director, Dr. Julia Brody, introduced in front of the President's Cancer Panel back in 2009. And what the emphasis here is that we needed a new way of thinking about cancer prevention. Cancer, particularly breast cancer, is a long latency disease. And we needed to shift our thinking away from this kind of linear thinking of thinking that what are the exposures? We're going to follow people for decades, and then we're going to see if we could see an association in the human studies or in the epidemiological studies many decades later. This new paradigm calls for actually kind of taking different pieces of evidence and combining them together, and then that should be the basis for action. So today I'm going to be talking at first about the work on the left, which is the biological mechanisms. That is trying to think about what chemicals have biological plausibility for contributing to breast cancer. Then I'll talk about our exposure studies focused on those chemicals, and then combine them to talk about some ways that you can have an impact on trying to reduce or prevent breast cancer. Okay, so let's focus on the left, that biological pathways to breast cancer. So there are many different pathways to cancer. At Silent Spring Institute, we focus on three, notably those chemicals that can act like carcinogens, meaning they can directly damage DNA. And in our oversimplified example here, that is ionizing radiation. We think about chemicals that are hormone disruptors, or EDCs, endocrine disrupting chemicals. These hormone disruptors promote tumor growth. So for example, hormone replacement therapy. What I should have noted on the when we were talking previously about combined hormone replacement therapy and its impact, is that many of those were actually, it was in the tumor progression rather than the initiation event of the tumor that was affecting breast cancer incidence among perimenopausal women. What that means is that the tumor itself may have been initiated, but the exposure to combined hormones actually caused the tumor to grow. And third, we think about chemicals that are hormone disruptors that actually alter our development, alter the development. For this example, what I'm showing on the right are kind of the branching in breast tissue, which can increase our susceptibility later in life. So one example of this is actually PFOA, which is a PFAS, which are per and polyfluoroalkyl substances. Okay, so let's think about what is some of the evidence that we use. I've tried to motivate that doing the human evidence is particularly hard, but what is some of the evidence that we use to think about chemicals and their association with breast cancer? Many scientists, when we're thinking about cancer, focus on animal models. Because although rodents are different from people, it turns out that the fundamental biology that governs breast cancer carcinogenicity or carcinogenesis is fairly similar between the rat and the human. Studies of chemical exposures in rats are usually good at predicting human exposures. We can see that by the concordance between those associations that are identified on the right side of the screen and the right side of this graph and those on the left. What this means is that looking at the rodent or the animal literature, we can identify chemicals that would likely cause mammary gland or breast cancer tissue, breast cancer in humans, and allow us to think about what biological alterations enable breast cancer development. Animal studies have been used not only in breast cancer studies, but in other cancers as well. Okay, now let's dive in. This is actually, I know, a very complicated slide, but I'm going to kind of walk you through it step by step here. So this is actually coming from a study that my colleague at Silent Spring Institute, Catherine Rogers, and others had done this kind of systematic review of the available epidemiological literature. So that's human studies on breast cancer and environmental chemicals. There's a couple things I want to point out here. The first is that over on the right there, you can see there's several of many studies that were designed in such a way that they were fairly nonspecific in which particular exposure window they were looking at. What's important here is that we know from animal studies and other studies that exposure to chemicals during certain exposure windows, say during breast development, maybe premenopausal or even post or perimenopausal, is really important in looking at the potential for that chemical to be related to breast cancer. The vast majority of studies, in fact, were rather nonspecific, looking at those exposure windows. The other thing I want to show is towards the biological activity. So the G there is representing genotoxic. Those are chemicals that have been shown to be genotoxic, typically in cell-based assays. Chemicals that are genotoxic, particularly when they're related to breast cancer, that is an indicative of chemicals that would be long latency, right? So a genotoxic event means that you alter the DNA, and then it takes years, decades even, to progress to cancer. The next column over, the RMC, or the rodent mammary gland carcinogens. Those are chemicals that have been identified in rodent studies as being mammary carcinogens. And then the next column over are endocrine active chemicals. Those chemicals that have been shown to be endocrine active in mostly in cell-based assays. So 2/3, so what's really important there is that they actually, we can use all of those kind of lines of evidence in that biological activity window to help us try to understand which chemicals we should be looking at. Now let's look at, I want to draw your attention to the fact that in the kind of the left-hand side here of the exposure window, we see very few studies that are targeting chemicals that we believe to be biologically plausibly linked to breast cancer to be studied at the right time. There is one example, though, of when this actually was done in a way that could show an association between environmental exposures and breast cancer, and that's for OCPs. That's for, this example here is for DDT. Rodent studies as well as cellular-based studies would suggest that DDT is associated with breast cancer. And it was only in a study that actually Barbara Cohn and colleagues had published just a couple of years ago that showed in utero exposure to DDT was predictive, or was a predictive of later breast cancer incidence or later breast cancer risk. That is a remarkable study in that it is kind of a unique opportunity to look at these exposure windows. What I mean by that is that they collected blood samples from mothers giving birth in the 60s, in the 50s and 60s, and then followed the daughters, and now even actually the granddaughters, for decades. And then they can go back and look at those blood samples. So and find actually an associated increased risk of DDT exposure. What's important there is to just highlight is that many of the regulatory agencies rely on human studies to classify chemicals as known carcinogens. But I would say that the bar is actually pretty darn high. To have, blood stored for decades, following women for years, that bar is pretty high. And so suggesting that, sure, this suggests that we can design studies, epidemiological studies, to better capture some very important exposure windows as they relate to breast cancer. But it also means that we need to rely on other lines of evidence, not just the human evidence, to show associations with breast cancer. Okay, so now let's move on to talking more specifically about endocrine disrupting chemicals. So these are chemicals that are, sometimes we call them endocrine active chemicals that somehow interfere with the body's hormone system. So first, I want you to kind of take a moment and think about the word pollution. What comes to mind? Is it a factory smokestack? I think most people think about that. They think about pollution as being an outdoor problem, but in fact, pollution is quite personal. We know that chemicals or pollution levels in our homes are often 10, 100 times higher than they are outdoors. What that means is that the products that we use every day, the food we eat, the air we breathe, the water we drink, all are sources of the pollution that we're exposed to every day. And that's a result of the fact that many people may not realize this, is that many chemicals can be added to products without adequate or comprehensive safety testing. And what that means is that many chemicals are added without their assessment for perhaps being endocrine active, or without going through any analysis of kind of long-term chronic health effects before they're added to the products that you can buy at the store. So let's talk about what are endocrine disrupting chemicals. Endocrine disrupting chemicals interfere with our body's hormone systems in multiple ways. It means they're not only associated with breast cancer, but they're associated with numerous health outcomes. So other hormone-mediated cancers, likely uterine cancer, testicular cancer, and so forth. They're associated with lower fertility and sperm quality and other reproductive health concerns. They can alter immune system functioning. They can result in neurological issues or learning development, learning disabilities in children. And also metabolic issues, including diabetes, obesity, and cardiovascular diseases, have all been associated with exposure to endocrine disrupting chemicals. Okay, now time for another poll. On a given day, any given day, today perhaps, which of these consumer product chemicals do you use? I invite you to select all that apply. Okay. Looks like there were, oh, people are still going. All right, let's have a look. Okay, so it looks like some of the biggest users are, some of the products that are most often used are, let's see, 53% of people say they use hard plastic water bottles. 50% of you are using sunscreen. Of course, 61% say upholstered furniture. 63% use cleaning products with added fragrance. 58% eat from canned food. Let's see, 84% use body lotion. So this is not surprising. We know that, on average, people are using, and these aren't all personal care products, but people use, around 10, 12 personal care products a day. And of course, there's, other exposures like upholstered furniture, right? That's not something you necessarily choose, it's in your house. But all of these are sources of endocrine disrupting chemicals. So I'll go through a couple of these in some of our research, showing some of our exposure research. So EDCs are found in products that we use every day, right? So bisphenol A or other bisphenols are used in hard plastic water bottles. And I say, oftentimes people think about polycarbonate water bottles. Those are those like Nalgene bottles. You can see they're labeled as BPA free. Unfortunately, sometimes they're replaced. The BPA is replaced with several chemical cousins, other bisphenol, like BPF. UV filters are used in sunscreens, but they're also used in a lot of lotions. They can also be used in the plastic of plastic water bottles. And leach out into the water. They're they're antimicrobials in the products that we use every day, like hand washes and different soaps, but also in different materials. People, who purchase things that have like microband, you can find them in anything from countertops to scissors. Of course, flame retardant chemicals are found in upholstered furniture. Phthalates are used as plasticizers in a lot of plastics that you may encounter, but they're also used in personal care products because they're incredibly good at carrying fragrance in products. Parabens are preservatives that are often used in personal care products that touch your skin, so cosmetics. And of course, PFAS chemicals, those per and polyfluoral alkyl substances, are found in things like nonstick pans and waterproof jackets, things like that. In fact, when we look at national biomonitoring data, this is data from the NHANES program, CDC's NHANES program, we can see that we are all exposed to endocrine disrupting chemicals. So this is for just a suite of endocrine disrupting chemicals, including the antimicrobials, those are at top. The parabens, those preservatives, are detected in nearly 100% of people. The bisphenols follow next, as well as BP3, which is a UV filter. And then finally, the dichlorophenols, which are in disinfectants, cleaning products, pesticides, and preservatives. So we know that we're all exposed to these chemicals. However, we are not all exposed equally. In fact, this is looking at methylparaben concentrations in urine and looking at separating by race ethnicity. And you can see that non-Hispanic Blacks have much higher levels of methylparaben in their urine compared to others. This is actually a reason why we have launched kind of a whole area of research that I'm not going to touch on too much here, but is looking at exposure and health disparities resulting from unique patterns of exposure among women of color. And this is based on some of the work that we had done earlier, product testing work that found hormone disruptors, or EDCs, in personal care products commonly used by Black women. Mostly these are hair products specifically that are marketed to and used by Black women. We also know that people are widely exposed to these chemicals, EDCs, because we've done a bunch of indoor exposure studies. In fact, I've collected hundreds of air and dust samples across the country, and I always detect things like phthalates in those samples. So our first study actually of looking in one of the first actually that was in the United States to measure many of these EDCs was our Cape Cod household exposure study that looked for 89 different chemicals, 72 of which would be considered endocrine disrupting chemicals. We looked in both indoor air, dust, and urine for these chemicals and found widespread exposure to many of these chemicals. Here are some of the results. We can see that on average of the 89 that we looked for, we found about 20 chemicals per home. We found 67 EDCs detected in total, including 27 pesticides. We found DDT in 2/3 of the homes. So this work happened about 20 years ago now, when DDT was banned 30 years prior. As a follow-up to this, we just did a study where we were looking at DDT in dust, and we still detect DDT now 50 years after its ban in dust. DDT is very persistent and just doesn't go away. As I said before, phthalates we found in 100% of homes. Parabens and alkyl phenols are quite abundant. Parabens, again, are preservatives that are used in products. Alkyl phenols are surfactants that are used in products. We found flame retardant chemicals likely coming from upholstered furniture at much higher levels than had been seen before. We found 15 chemicals exceeded health-based guidelines for when there were health-based guidelines. And 80% of the homes actually exceeded health guidelines. And overwhelmingly, and this is another area of research that I won't quite touch on in today's, but something that Silent Spring is very active in is how to share these results, these kind of results, with study participants. So we've extended our work beyond Cape Cod into Northern California, seeing very similar trends in terms of the ubiquitousness of many of these chemicals. We've even extended it into low-income housing, looking pre and post renovation, as well as in housing with asthmatic children. and even on college campuses. We have a program called the Healthy Growing Campus program, where we're looking at studying persistent chemicals, including flame retardants and PFAS, that are found in residential and non-residential spaces on college campuses. So in our first analysis, where we looked at dorm rooms, we actually, 2 different universities, we found 47 detected flame retardants in dorm rooms. And then in a follow-up study where we actually looked at 4 universities, we found 43 flame retardants in non-residential spaces on campuses, things like classrooms, libraries, things like that. So these chemicals are in our products, they're in our homes, and they're also in our bodies. So I showed before some national biomonitoring data, and now I want to share some results from a study that we conducted called what's a crowdsourced biomonitoring program. So this crowdsourced biomonitoring program, we had over 700 people across the United States mail us their urine samples, and also answer questions about their exposure-related behaviors, kind of what products they're using, what are their dietary habits, and things like that. And then we tested these urine samples for common household product chemicals. We found that the more products that you use, it leads to higher concentrations. So this is the number of personal care products used in the last 24 hours and methylparaben concentrations. And you can see an increase. And it's not surprising, right? Methylparaben is a very common preservative in many of these, many personal care products. So we can now associate or link product use with actual exposures. Of the 10 chemicals that we looked at, most people had 7. And the importance here is that we are not exposed to one chemical at a time. In fact, we're exposed to multiple chemicals at a time. And these exposures can add up. What's more is that many of these chemicals act in a similar way in our body, right? So each paraben is estrogenic. That can actually increase estrogenic response in our body. BP3, a UV filter, is also estrogenic. And so the takeaway here is that it's not one product, one exposure, one chemical. It is actually multiple products that that people use every day, multiple chemicals in these products leading to multiple chemicals of health concern in our body. So I've talked about how these chemicals, why we study the chemicals that we study, what that means for breast cancer, where these chemicals can be found in our everyday lives, mostly focusing just on those endocrine disrupting chemicals, or EDCs. Now I'd like to shift focus and talk about ways that we can reduce or limit our exposure to these chemicals of health concern. So I'd like to talk about exposure reduction actually happening across multiple avenues, right? The first is at the consumer level. But this does not have to happen in isolation. And one effective way to try to reduce exposures is to actually change your personal behaviors. In the crowdsourced biomonitoring program that I had introduced, we actually saw people who read product ingredient labels could actually significantly reduce their exposure to chemicals like parabens. What that means is that there are steps. You can being a more conscious consumer, you can take steps to actually reduce your exposures, and it will work. And many of these chemicals tend to be have short half-lives, which means that they're not in our bodies for very long, which means that you can have an effect over days at reducing your exposures. Many of these tips to help people kind of become more healthy consumers are aggregated in an app that we have created called Detox Me. This is a free app. It's available in Spanish and English for download, and it includes over 270 research-based or research-backed tips for reducing your exposure to EDCs and other chemicals of health concern in our everyday lives. So I'm just going to quickly talk about some of those tips that come from the literature and are in the app. So avoid things like air fresheners, scented candles, and potpourri. We know that many phthalates are used as, which are endocrine active chemicals, or EDCs, are used as carriers for fragrances. So avoiding air fresheners can limit your exposures to phthalates. We also know that some synthetic fragrances are themselves EDCs. And so avoiding particularly synthetic fragrances can reduce your exposure to EDCs. Ventilation is important. Some of these chemicals are fairly volatile, meaning they're being in the indoor air, we're breathing them in. So increasing ventilation when it makes sense can reduce your indoor air levels of some of these chemicals. Look for alternatives to flexible vinyl. The easiest thing here, I always tell people, is replace your vinyl shower curtain. That's just a big piece of phthalate hanging out in your house, which off gases you can smell, right? Like you can smell some of those chemicals coming off. In our product testing work, we found that that's about 25%, about a quarter of that vinyl shower curtain is DHP, which is one of the more potent phthalates that has been connected to reproductive development issues, particularly in boys. Of course, choosing rugs and furniture made without flame retardant chemicals. This is now possible because of changes in flammability standards, but you should ask for it when purchasing a couch, for example. Eliminate mothballs, of course, which are carcinogens. And for pets, avoid the use of pesticides instead of actually applying, especially if you have little kids. Okay, quickly, the cleaning guide. Avoid antibacterial, antimicrobial. Pick up dust, remove dust in the home. Dust is an incredible reservoir for chemicals in the home. Many of these chemicals are persistent. That's where the DDT was hanging out, was in the dust. So reducing your exposure to dust itself will reduce your exposure to chemicals found in the dust. Keep it simple, clean like your grandmother, clean with plain water, baking soda, vinegar, and Castile soap. Avoid disinfectant sprays. Choose fragrance-free products, of course, and avoid cleaning products like treatments that you might apply to fabrics that are say that they protect against stains, as they may contain PFAS chemicals. Of course, it's always good. Keep it simple. If the product has poison or danger right across the label, that may be indicative that it has a chemical that you may want to avoid. Okay, so that's the consumer level. That is only one part of the equation here, though. We need to think more broadly. It cannot be solely on the onus of the consumer to reduce their exposure. Rather, there's other ways we can do this. We can engage with institutions like the Cancer-Free Economy Network, which is a kind of a network of scientists and organizations that are working to reduce chemicals that have been associated with cancer in our economy. Also, things like our Healthy Green Campus project was actually born out of this idea. This idea is that if we engage with higher ed across the country, that we can influence their purchasing decisions and affect exposure on college campuses. You can also have some market shifts. You can engage with different markets. This is actually an example that comes out of our flame retardant research. Back, way back about 20 years ago, we were the first to measure flame retardant chemicals in indoors. And then when we extended that work to California, we found significantly higher levels of flame retardants in California homes, as well as Californians themselves and their bodies. This and other research, as well as research showing the lack of effectiveness of flame retardant chemicals when they're added to upholstered furniture, led to a change in the standard and into the regulation. But this also was because there was added pressure on the manufacturers themselves, on the upholstered furniture industry, to move away from adding flame retardant chemicals to their products. And so this is now you can buy, if you look for this label here on the right, you can check the tags and you can buy flame retardant free upholstered furniture. Okay, so there's things that consumers do. I share the Detox Me app, but those are just personal behaviors that you can institute or that you can change that will limit your exposures. Of course, engaging with institutions around purchasing specifications. You can opt into phase outs like the Mind in the Store campaign and others that are working to put pressure on manufacturers or retailers. And of course, at the regulatory level, standards changed, thinking about class-based approaches to chemical management. to really have an effect, to really have an impact on our ability to limit exposure to EDCs, we have to work along this continuum. We have to scale our action onto multiple levels to be most effective. So quickly, just some ways to get involved. What you can do, one of the #1 things you can do is just vote. Get involved, support state and federal policies that are aimed at limiting harmful chemicals, support advocacy groups that are working in that area as well. Also, put pressure on manufacturers. For example, the Home Depot has banned PFAS now in carpet and rugs that it sells because of pressure by a lot of advocacy groups, but also consumers. There are several other examples. For example, Safer States, which is an organization that's pushing and supporting policies at the state level, have introduced various bills across the country. This example is New Hampshire has a bill to prohibit the use of BPA and BPS in paper receipts. Also working on trying to eliminate PFAS in food packaging. So supporting these bills can be really important and kind of help kind of have added or kind of ripple effects to reduce exposure for a wide range of people. And of course, globally, right? So Denmark actually became the first country to ban PFAS from food packaging. So that's happening at the national level, which is pretty remarkable. So I've talked a lot about our research. I've talked a lot about kind of what are the causes of breast cancer, tried to motivate the idea that environmental contributions or environmental factors can contribute significantly to breast cancer and other cancers. I've talked about how we think about chemicals, how they can be carcinogens, they can be endocrine disruptors, they can alter susceptibility. I've talked about what are some of the evidence that we use both in the animal-based studies as well as the human studies at looking at the link between environmental chemical exposures and breast cancer. And then I've talked about our exposure research, our research on thinking and characterizing these chemicals in our homes and the products we use in our bodies, and linking that to behaviors, thinking about ways that we could try to limit our exposures to chemicals by altering our personal behaviors, but also getting involved at various scales, right? Getting involved in institutions that are working in these spaces, getting involved in market campaigns, and getting involved in regulatory or policy decisions. So I encourage you, all of our research is on our website, silencespring.org. I encourage you to check it out and learn more about some of this research. So real quick, just want to circle back to some of those top tips because I always get asked these questions, so putting them out there right now. So my top tips are always to look for paraben, phthalate, and fragrance-free products. Look for products that are transparently labeled, meaning that they are disclosing what is in the products and in fact might say things like that they are paraben free. Eat more fresh foods instead of packaged foods. Reduce your exposure to several chemicals, including PFAS chemicals, as well as some phthalates, as well as things like BPA. Keep dust levels low. And by doing that, you can reduce your exposure to chemicals that just like to hang out in dusts. Those legacy chemicals that we often think about, pesticides, but also flame retardants and PFAS like to hang out in dust. Steer clear of products that are advertised as stain resistant to avoid PFAS exposures, and keep it simple. Use DIY cleaners and other ways. Basically, when choosing products, keep it as simple as possible in your everyday life. So I've talked a lot about our research. All of that, of course, is annotated on our website. You can learn more. These are all the references that I've cited in our in the presentation. So thank you, and I'm happy to take some questions.
Thank you, Robin. I see a couple people, Robin, asked about the presentation slides. So wondering if they could have access to the slides. So
yeah, we can make those available, and of course, this recording I think is available as well. So
okay. Yes, the recording will be available on demand, I believe. Anybody else? Any questions? I did drop those resources that I mentioned in the beginning in the chat. I'm also going to put in the Cancer and the Environment Network of Southwestern Pennsylvania. If you'd like to get involved, there's great information on there, and we're always looking for new people who are interested in helping spread the word and be a part of these projects. So, all right. Well, thank you, Robin. I've heard it a couple of times, the presentation. Every time I learn more. And so I really appreciate your time. I'm sure everybody else does as well.
Thank you very much.
All right. Bye-bye.